Alright, hi everyone, welcome back to the building a compiler in Zig series. So I think what we need to do is parameters, because parameters are pretty important. I guess the main problem you have with LLVM and why it's a lot harder to do LLVM than C++ or converting to C or something like this is you have to track the variables. For example, with return, you have to know what the return type is. And also you need to kind of convert the variables over. Say if it's a struct or something, it's a bit more complicated. Because if I were converting to C++, it'd be very simple, really. But we need to do parameters, so first we need to do that. So I'll just get the code quickly. So I guess I'm just trying to remember where we are. Yeah, we have we've made it null for now, so we need to get in expression script. We need to fill parameters. So I'm going to find that quickly. Of course, we're going to have to do the rest of these at some point. That's just when we get to that. But for now, we're going to do this. But we're going to get some errors. Pass single. We need this. First, I'll just go through this code. So we set the error function, obviously, so we know where we are. Child list create init capacity. So basically, we have the child list. So I believe that the parameters are just child lists. That's all they are. They're just lists of AST nodes, and each AST node is a variable. Create default. I guess you can have variadic parameters. I'm not sure exactly how you do variadic parameters in that's how printf works anyway. I'm not sure how it works in default. I mean, a lot of your implementation in the language depends on how easy it is to implement in LLVM. So generally I just try to get things working, and then later I'll experiment. How do you do variadic expressions, things like this. I'm just trying to get it working right now, because you could just have basic parameters and then work out how to do variadic parameters later. So we're checking for an infinite while loop just in case, I'm stupid and actually make one. Do I really need printing? I guess it's just for debugging. Yeah, so we're basically calling another function. That's all we're doing. Loop through the tokens, get this function, and if we find a right parameters, we break. That's pretty much it. Let's get this function, pass single parameter new. I bet you 100% this is going to be a chain of functions. Create complex, again that should be lowercase, and the allocator should be first, and the allocator should be first when we're calling this as well. Allocators first, possibly we need the allocator first. AST data, and we create complex declaration. We need this, it's declarations. Allocator should be first. AT data is also in the wrong format. You can tell I copied this code from C#. It's going to be a massive chain. So like this needs this, and this needs this, and this needs this, and this needs this. It's just a massive chain. Alright, I need to make this lowercase. You should put allocator first. As always, you've got to put the allocator first if you want to follow the style guide. Or what everyone does anyway. We're going to make this lowercase. We're going to put the allocator first. But the reason why I didn't put the allocator first, well, one, I forgot that you needed to, which normally helps. And two, I thought, do I need an allocator? I'm not sure. Okay, I'll add it later. Add it later at the end. So that's basically why. Easiest to add it at the end. Complex in a loop. Add the allocator at the start. I went page down instead of this. Okay. Just make sure everything's fine. We close this. Any errors? I've got no errors for now. But the compiler will give me errors because this is Zig. Okay, so first of all, handle inner loop. I'm trying to remember exactly what we're doing here. I guess I had a null check before that I got rid of. Not sure exactly if you need that, so I'm just going to leave it. Copy node values. I don't remember what that does. AST utils copy node values. Right. We're copying one node from another. That's what we're doing. Okay. To attach the type. I mean, this code actually is complicated enough for me to not remember how anything works, because it's actually it's basically it uses recursion, and it's kind of complicated. You kind of can forget where you are in the recursive loop a lot of the time. Also, you can't really... I've never found a way of actually using breakpoints in Zig, so I kind of use breakpoints to work through the C# code to try and understand what the hell is happening. Still kind of confusing sometimes. Alright. So we have this thing, loop result. Does that exist? I don't think it does. Let's find where this exists, shall we? Literally all we're doing here for loop result is just simply, I want to extract functions, because it's very annoying, because you can't return a return. Like, I want to break. Return that you want to break. Because I want to extract functions. Because it's just neater, a lot more readable. I basically use loop result for that. It still is not going to find it, but it is there. Basically, I'm using loop result for that, so I can know when to break. Close this, don't need it. Because otherwise you'd have to put this inside this function. It would be very unreadable. Anyway, I don't know if this is going to work, so we're going to have to create a test to see if this is going to work. First we need to call it, which would normally help if you want to actually use a function to call the function. I don't know if you know that. So we're going to do this. Try expression fill parameters, which does exist. It doesn't. It does exist with the allocator first, which we have got. We have it try, and it is returning an AST error. This doesn't return an AST error here, so I might have to change that. I don't know. We'll see. It also isn't optional. So do we return null at any time? I don't think so. We're returning a loop result, so it doesn't matter. Anyway, we're gonna have to test this. We're probably gonna get errors because we're using Zig. All we do is get errors. It's like an error simulator, is basically what it is. Alright, we'll see if we get errors just from calling it. So Zig build run helps to spell it right. Zig build run, we do got errors. Child list, children, 34 expression. Because we've changed the name, so I'm just going to fix all these name errors. Then I'll come back. Okay, that runs right. Okay, we fixed all the errors. They're exactly the same code from before. So what I'm going to make now, I'm just going to make an add function to try and get this to work. Obviously it's going to give us probably a load of errors because we're using Zig. So let's go to core, we're going to go to code samples, and we're going to write a code sample quickly. Alright, so we're going to use this add function. So I mean the problem with this is that it's actually pretty complicated in LLVM to know what the return type is, and then put that in. So we're just going to presume for now, before we've done anything, we're just going to presume everything's an I32 when we return it, because it's a kind of pain. You basically need to track all the return types of every function. I need to track what var type everything is when you actually find out if something exists or not. If it doesn't exist, it's going to give you an error. I mean, at least LLVM errors are actually pretty good, so you will get that. So let's go back to main.zig, and we are going to, instead of this, we're going to go add. I think it was called. Just check that. It's called add. It's public. All right. And let's see what happens. We'll probably get errors. Okay, we didn't. That's actually surprising. We got an error in the expression. Why? A. Right. Okay. That's a good sign. So we have that error working. Add parameter. It's okay. We have this add parameter thing here, which we don't need. It's just for debugging, I guess. Let me just run this again. I want to make sure the error is on the right line. It is, yeah. Error on line 1, 6. Unexpected type. These line numbers are wrong, so I should probably fix those. Because the so I think we're going to go line 1 plus 1. I think we need to do that because we're on line 2. Yeah, so error on line 2, 6. 6A. In theory, we could count and do what Zig does, where they what Zig does will do something like, it will have the code. Say, for example, we have code here, code here. Let's say, like, I don't know, return A, whatever. What Zig will do is this. It will go. You know how to write this square. This one, square line, square line, square line. Da, 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 da. There. It would do that. We could do that. That would be better in the future. We can maybe think about doing that later. Well, I've got to test if the actual char value works. But our error messages are fine, are good enough for now. So it's on the A, so it's not expecting an A, because we're not expecting an A. In our expression, for example, if I close all the rubbish that I have open, this, here we have a lot of early returns, but we go is binary operator bool, get precedence bool. Where does this actually go? Get precedence bool. This is an util. I'm trying to remember where actually we're going here. Pass binary expression any, because we don't actually know what it is, and we got pass primary any. And then if it's an identifier, we skip. So we need to put in here pass process identifier, and we need to copy that because it's a scaling no random chain of dependencies. So just as I promised, this also calls 3 other functions. Hooray! Because basically an identifier could be a function call, or it could be an array, or it could be just a general identifier. So basically we're getting the next token after this, and we need to make that not this, and we need to put the allocator first. This just like, it never ends. Process binary expression is lowercase, the allocator is first. The allocator needs to be first. Let me just fix the first token. It is in the wrong case, otherwise it looks like it's using a function call. First token. So what I'm also going to do, I'm just going to search for dot token. You know, this function call function is pretty big. It's pretty big. We need that to be lowercase and pass binary expression. This is probably the most complicated part, is just the binary expressions. And we also need to simplify the binary expressions, which is fun, which is a load of fun. It really is. Because LLVM will not let you do complicated, because literally if you're just converting this to C++, you would literally just write it as it is, and C++ compiler will do the rest for you. We're going to dot token, and preferably, I think that's fine, dot token, and then dot node type, dot node type, then dot left. That's a problem. That's going to create some false positives. Yeah, that's a problem. I'll have to get the compiler to fix that. Process function, that exists, doesn't it? Unless it's got the wrong name. It probably has the wrong name. It needs to be this, and the allocator needs to be first. I don't think you've heard me say that. You don't need this. It's pointed to allocator. All right. Init capacity. This needs to be children. Right. I don't actually remember what this is doing. So, function call. When we use a function call, what do we do? I think what we're doing is a function call. We're looking for the parameters we're putting into it. Is what we're doing. I think. But anyway, function calls we'll do later. It's not important to do now. We are just trying to get a process array needs to be this, and the allocator is already first. At least fourth token dot type. Okay, we don't have print line yet. I realized I didn't do that. What? We are not doing print line yet. So where the hell am I? Alright, I just realized I did this. So what we're going to do is just call this. We're going to go add. Let's go I32 results, whatever. Add result equals add 10 plus 10, whatever. And that means we'll have a function call. We will get an. We've got an. Okay, what's happened? Segmentation fault. That's always fun. We've got our first segmentation fault out of this. That's always fun. It's probably the fact that we're creating. We print AST nodes. Obviously, it's in AST nodes. Function call. Yeah, it's in the parameters. So we're going to go to parameters and try to fix that. Get off my screen, please. Parameters. Fill parameters. Do we create a stack? Right. Yeah. Here's a segmentation fault. So this is what I had before. Basically, we don't have it on the. We're having the. So if you put a pointer on the stack, and then you add that, we're gonna add the whatever this pointer is on the stack and linking to that pointer. It's gonna be basically be invalid. So we need to make this on the heap. So we're gonna go fill. We're just gonna copy and paste this because we're lazy. Put it here. How exactly do we do this? Yeah, we just so I'll give it the same name so I don't have to rename everything. Go children list, and then we go children list pointer equals that. And that didn't work for some reason. Why not? I don't know. Because you have to go dot, because I'm forgetting how Zig works. Dot. That should get rid of the segmentation fault. Should. Got an error now. At children, it shouldn't be at children, it should be children list. That should fix it. Okay, we got rid of the segmentation fault. Let's see if people don't understand what's happening here. We create an array list on the stack, which is basically just a pointer. Basically, it's just a pointer, really. Pointer to the first element, I believe how it works. I'm not sure the exact implementation. Then we put this into here, and we're basically putting a reference to a stack variable. Stack variable contains the pointer. Then the stack gets cleared because we leave this function, and we try to print it later, and it gets cleared, so it's nonsense. And we try to access a nonsense. We try to access a nonsensical, like invalid memory address location, and we probably don't have permission to that because it's very unlikely we will have permission for that. So we get a segmentation fault when you try to access memory you don't have permission to access. That's basically what a segmentation fault is, and this fixes that. So let's look at what the hell we're doing now. So did we get an error? We did not. So this is nonsense. Look at this. we're putting plus. That's great. Obviously, we haven't implemented this for because we need to simplify the expression. But we have this define i32 at void. That's actually correct. We have the entry point. We just got to fix the return. And then here we're not actually calling anything, probably because we don't actually have anything but return. So this project will take a long time. If you don't realize that, it does take a long time. We have to basically implement everything ourselves. We're not using anything to help us. Alright, so let's go over to, let's close everything first of all. Don't need most things open. Close core. We need to go to convert. LLVM convert. Alright, convert is the first function, I believe. So we have convert data, we go append line. Right, printf, just because we will printf later. And then process global token, global node, which comes to here. Function declaration. We have declaration or function declaration. So inside function declaration, we need to process the body. Then we process function body, amount of infinite loops we have. Okay, here we just have return. See, that's why it does nothing. So here we have a declaration and a declaration that will contain a function call node. Basically what we have. So we're going to have to do this, and we get errors because I haven't created it. It's called CPP declaration because I'm copying it from the C# code, which converted C++. We're not converting to C++, obviously. But we do need return. And we need to fix the return. What I think I should do first, instead of creating a whole list of dependencies, this calls to this calls this, let's fix the return first. So we first need to flatten expression, which is the big can of worms itself. Because basically we need to convert. We basically need to get a node. I think we convert them into string. Here's where I actually forget how anything works because I don't remember. So we have a list of string. So string is what we're using. The problem is also we need the return type. But again, we're just going to presume it's i32. All right, hi everyone. I I've been working on this for a while. Basically, a whole day it took me to get this working. I'll show you where we got to, and then I'll show you the code. So basically what we have here, we should probably fix the spacing, but it doesn't matter anyway. So I have the parameters now working, which is really actually quite complicated. Then I have the return value, add i32ab, which also should have a percentage. I need to fix that. We can do that in a minute. Well, I can do it later, I don't know. And then we haven't got the return working at all, because I've got to basically this takes a long time to do. The problem is, if you convert to, like, say, Go or C++ or something like this, it generally does the typing for you. So I'll give you an example. So say, for example, we have, in our language, it will be fn i32 add int, sorry, i32. Say I wanted to convert this to Go. I mean, basically, we would just change fn to func. We would put add here, and then we'd flip the order, make this an int, b, make this an int, and then we'd put an int here, and then we would do this, and we would just do return a plus b without the semicolon. That's how you convert to Go. You want to convert to C++, it will be similar as well. You'd go, instead of this, we would go, probably do std, whatever. I'll call it just int, just to be sure, just be quick. Int a, int b. You can't do this in LLVM. Instead, what you're going to do is we're going to go. So instead, we convert this to define add, and it's going to be like an add. That's what it's going to be. i32, which is actually the same as my language. You want to do percentage a, i32 percentage b, like this. And then we can't just simply do this. What we have to do is we have to set the value. We can't return, and so we basically, there's two ways in LLVM how you basically create a variable. There's either a register or there's RAM. And a RAM is, say for example, we do something like this. Let's say value. Say add i32 a, percentage b. Like this. So this will be a register value. It's a register. It's put into a register. It's a constant. You can't change it. What you could also do is do this. Let's say var. And we're going to call this alloca i32. I think that's all you need. I don't exactly remember. I'm not really an expert in LLVM. So this will be commented on like this. Commented on with semicolons in LLVM. Kind of weird. Anyway, this will be what? This will be in RAM. In memory. This will be in a register. You can't obviously change the value if it's in a register. And then you do return ret i32, let's say value. I don't know, something like this. And get rid of it. We can get rid of that. I'll keep it there, whatever. So this, like, I have to know what the type is. I have to track what the type is. So I have to track it's returning an i32. Yeah, sorry, it should be define i32. Define i32. So first we need to know what the type is, and we need to specify we're adding i32, and we have to specify that we're returning an i32. So you need to track this stuff, and you can't just put return a plus b. It's invalid. You got to separate each thing. So that is a lot harder. And then there's the fact that I'm copying this from C#, so it's more complicated. I'll give you an example. So I have this thing which I don't have open. All right, here's a good example. So we have flattened binary expression. I think I went through this kind of last time. We need to say we have, I don't know, say we have int number equals a plus b minus function divided by 10. Put this in brackets. This in something like this. You basically have to separate this into loads of nodes and then kind of put it all together into separate declarations. That's kind of what I explained last time. So we need to do all that. This is what flatten expression is doing. It's basically, it's converting that into like it's converting that into actually the printable format is what we're doing. We have a load of checks. We create left statements, which is an array list, which means we have to create on the heap, just because I don't want it to get a segfault, just in case I do. In theory, it will get cleared anyway. Really, it doesn't really matter if I put it on the stack or the heap, because I just want to print it. But I'm just doing it just in case. It will get cleared anyway. I'm using it'll get cleared anyway because I'm using an arena allocator. So I create these left statements because it's basically left something, left plus right, maybe. So we create that, we flatten the expression, we create the right, we flatten the expression, then we get the token text from this. Also, you get all the nullable types, which is always fun. You got the token.null check.text, and I've also got to check all the nulls. We get the LLVM operator type, which again I think I don't remember. Operator type is this one. So I'm just presuming everything's an I32 because that will take. I just want things to work for now. I'll add it later. Does my code work? Well, let me just implement 10,000 features, and then obviously I'm going to do it part by part. So I'm just going to presume everything's an I32 for now. Because, LLVM is more complicated than anything else. But I'll show you this in C#. Alright, so this is what this looks like in C#. It's quite a lot easier, honestly. You just have some asserts at the top. You create left, it's a list of strings. You create right, it's a list of strings. You flatten them, put the temp var in, put this line in. You make the line yourself. You add the ranges, and you're done. Compare it to this. It's quite a lot more code. You got all this error checking. Zig is just generally harder than a managed language. You got all the error checking. You got all the plus. I mean, I always had this problem where I say if I flatten the expression, I don't even know where that is now. I think I found it. This is actually for creating the parameters. So we have this final node here, which in the C# code is actually null. But the problem with setting it to null is I set it to null, and then I either set the value when I go to another function, but you can't. Parameters in Zig are immutable by default, and they're not immutable if they're a pointer, but the pointer itself is immutable, but the data you point to isn't immutable, unless it's a const pointer. Basically, you can't change the address. Because if you make this null and then change the address, you're assigning to a constant. It doesn't work. If I want to assign to a constant, then I'll basically go insane trying to do it. So basically, I just set the default value and then just checked if it was here, if it's invalid. That's basically the same as a null check because I set it to invalid anyway. And then you can't, like in the C# version, you literally just say final node equals type node. You can't do that here because you're resetting a pointer. So we just copy the node values and we just copy it over. It's just stuff like this. So it's the combination of using LLVM, having to track all the types, and you can't just simply say return A plus B. You create a temporary variable. Is it in RAM or is it in a register? Is it permanent? You got to work that out, and then you got to return to that, and you got another return type. I might switch languages to C++, and that will make things a lot easier, make my life a lot easier if I'm not converted to LLVM. But we'll see where we go, because I might go insane trying to do this, and it took me a day to get this working. All right, I probably don't even remember what I was doing, so I'll go through parameters. All right, so in expressions, we have fill parameters, which again goes from function. We go to function. Where are we? Print parameters. We can get rid of that. Yeah, so first we need to get it, so we need to go to AST functions, and then into this, not this, wherever the hell we are. I don't know where we are. You're probably not following a word I'm saying. Here we have parameter node fill parameters, which is in expressions. So we fill the parameters, and that will basically go in the middle. If I show you here. Here we have the AST light thing we have, whatever. So we have the function declaration add. In the middle, we have the parameters. So that's where parameters go. They go in the middle node. And we have to have parameter A, I32, parameter B, I32. That's how it works. So we fill the parameters. We come back to this function. We create the child list, of course, on the heap. Then we create the default nodes for the parameter nodes. We set the child list to that. we set it to parameters. These are a parameter node. Then we basically loop ahead, and we loop and then add parameters depending on what they are. And that could be quite complicated as well, because we have create complex type, which could be like, it could be a pointer, it could be const, it could be an array. I have it just for future proofing. We don't support those yet. It's just in case we need it, but generally now we're just going to presume it's one type and then not make our lives really difficult. So we're just going to have when I said this was a hard project, this is mostly why. It's the kind of simplifying the expressions, flatten the expressions. That's the hard part. And then there's LLVM, where you have to track all the types. And then LLVM, even printing stuff. When I show you what it's like to print stuff in LLVM, that's what it's like to print stuff. So for example, here, this is basically me making what I want to make, just so I know how to write it. So we have the add function, which we have the return value, which again, this will put it into a register, put the result into a register. And the reason we need to know the size is because i32 is 32 bits. We need to know the size so the register knows what, it can put into a 32-bit register or a 64-bit register. It needs to know the size, otherwise what's it doing? It's very low level. So we create this value add. I don't think we can return this directly, so we have to put it into a register and then return it. And then we put this value here, we call, and we got to say i32, say what type it is. It's an i32, so we call add i32.5, and we got to put i32 when we call the functions as well. So like you can't just say, add a bracket or a comma b. What? 10 comma b? No, you have to go i32 5. So we have to I'm not even sure. You'd have to work out. So this is an i32, so we should infer that it's an i32. But if it's an i64, we should infer that it's an i64. I'm going to go insane doing this. And then all we want to do is just print the output. We have to do this. So we create an array of 3 i8, which is just a u8. It's a character. A char array, a char. Format pointer is we get the pointer of the first element, which is kind of complicated, and then we set that value. I don't even remember what we're doing. We're storing at format pointer 37. Yeah, right. So we get the pointer at the first element 0. See here 0, and then we set that to 37, which is the percentage sign. Then we get the pointer at the second, the 1 index, and then we set that to 100. The alternative to doing that would be to create a constant if you want to print, but then the constant will always be the same, and you have to create constants for every time you want to print, and you'll go insane either way. This is just 100 is D. Literally all we're doing is that. Percentage D, new line. That's all we're doing. Or null terminator, because it goes to libc, so we're going to have a null terminator. We're going to have fun with this project. And then we put in the format pointer. So we need the format pointer, which is this one. So it's the pointer to the first element. We have the format pointer. Also, just to have fun, you need the null terminator, otherwise C will print forever and probably give you a Segfault. We have to work through C. I'm not sure if... I think Zig writes its own printer. It doesn't use printf, because Zig doesn't require libc, but writing your own print function requires you to be basically so writing your own print function that works with Windows, Mac, whatever, would basically Alan Turing would have a hard time writing that, because that is years of work. So we're just going to use printf and libc and then not go insane. So after all that, we literally just print out that, and that will print out 12. Because, if I wrote this in C... Alright, so all of this is literally just that in C. But we have to basically convert this. My language is almost the same. You basically just take this to i32 and put an fn here. Put an i32 here. Put an i32 here. Put an fn here. Put an i32 here. Put an i32 here. And then call this print line or whatever. And then we have exactly the same thing, but we don't need that. Most likely we can just print it directly. That's basically what my language looks like. It's almost identical to the C code, really. But anyway, that we have to convert it to that. Anyway, it's complicated, right? I think you get the point. So I don't even know what I've added, because I've added so many things that I probably don't even remember. But the code is in the description if you want to copy it. So we have fill parameter, which basically just loops through and finds all the parameters. Breaks when we find a right parenthesis. We add the parameters. That's basically it. And we have this complex types. If it's because it could be const, it could be. There's lots of things it could be. I think parameters should innately be const. Well, I think they already are. So I mean, again, the problem with this. So say for example, if we want to have a mutable, parameter in LLVM, what you have to do is you basically have to give this a random name. So you'd call it like, I don't know, temp or whatever, or I don't know, parameter A, parameter B, and then you'd create a local copy of that after the entry point, and you'd say alloca because you want to make it mutable. So you do what? Percentage A, so the user can actually use it, because otherwise you can't use it because no one's going to expect param. So if you make it constant, you'd make it this, and if you'd make it mutable, you'd make it this. And then I'm going to go insane trying to explain all this stuff. Would be alloca I32. I don't remember if you add anything else. I think that's all you write. Yeah. Then we go I don't remember how you set the value, to be honest. It's been a while since I've actually used this, but you'd set the value to whatever. Store. You store 1 in I1 is true. The weirdest thing is I1 is actually a pointer. Oh, that's even more confusing. So alloca will actually give you a pointer to memory on the stack. So A is actually a pointer, so we need to go store. I don't even remember. Anyway, you basically have to create a copy of it. It doesn't matter. So if you want to make parameters mutable, they are immutable by default in LLVM. So you have to actually make a local copy in every function automatically for the user. Anyway, so we add the parameters, right? And then we need to print the parameters. So I'll go to that code wherever I can find it. So in convert, we have function. We have right function and parameters. Before we commented out, but now we say if node.middle not equals null, we print the parameters, because then if it's not null, then they have parameters. We print the parameters, which basically we check if it's null, which might be redundant, but it might be null. I don't know how that could happen. Maybe magical. I don't know. Just to be thorough, I'm just going to say, is it null or not? And if the children are null, it's also a problem. We also have to use the great optional syntax. And here we have to use the great optional syntax, which is always fun. You wonder why I didn't use this, because instead of child count, you have to do this. Node.middle.optional children.optional.items.len. You think I really want to do that? No, I'm just going to make a local copy and put child count to make myself not go insane. Okay, anyway, so we get the child count, and we also copy the middle. We don't make it an optional, because otherwise I'll go insane. Then we get a child. We're basically just printing the parameters, really. I'll try to... Okay, this is just error checking. Parameter name should be in snake case. Would be nice, because this is Zig. Then we get the parameter name, which is the text of the token, I think. Yeah, if we look here, see we have this, the token is here, so it's A. So the parameter name is the token. Then we get the type is the left. And I guess we have to set, I'm not sure if we're just presuming it's a simple type. I don't even know, honestly. I guess we're presuming it's a simple type, because otherwise we have to parse the expression, we have to flatten the expression, which is always a load of fun. This is a fun project. Welcome to making a programming language. It's complicated, right? So recursively loop for the last node and expect it to be a type. I'm guessing we do this, I don't know. But basically we create a var, which is an optional pointer. We want it to be var because we're going to set it to something else. We set it to this, go through, set it to this, go through. We're basically looking for the base type is what we're looking for. Just because it could be like, it could be an array of strings or whatever. So it could be something like this of an array of string. So string would be the last type in that situation. Or you can have an array of a pointer to an int, and the int would be the last one, or i32 or whatever. Anyway, we're just looking for the last one. I don't remember exactly how this code works. We're seeing if that's null. We're seeing if that's null. If it's null, we show an error. Otherwise, var type. We get the var type, which should convert into an LLVM type, just because we need to know what the type is. Convert to LLVM type, it could be i8, i32, i64. In this situation, it's probably going to be an i64. Then we wrap it in the main. We basically have a load of stuff just in case I'm using... This is for C++, I guess. We're using slices or whatever. I don't know how to do that. I'll do it later. Because I actually, in the C++ version, I made a slice as a kind of my own struct. Which is basically just a pointer and a length. That's all it is. Just to make arrays simple. Like, you don't have... Because in C++, you don't have a size of an array. It's not default unless you use std array. Anyway, we're not talking about this now. I'll probably make an equivalent in... I'll make an equivalent in LLVM. Right, and basically, yeah, that's what we do. And this prints out the parameters. If I show you this, this prints this. So it prints i32a, i32b. Quite a lot of work just to do that. And we haven't actually... we're not done yet, because we haven't actually done... We're only doing returns right now. That is literally all we're doing is just returns. So yeah, that's all that works. So in this part, we have i32 add result, which basically means will need to be separated into a function call separately, I believe. I'm not sure exactly if... So what, in theory, what I should do is, if it's basically the rules of my language, it's like, it's basically like C const i32 value equals 10 or whatever, I don't know. That would be a const value, so it probably should be on a register. And then the i32 value number equals 10 should be on the stack or a heap. Well, I'm not sure how to do stack or heap yet. We'll get to it later. That's like stack or the heap. Who cares about that? That's like thousands of years in the future. Not thousands of years, but how many things? So if statements, for loops, while loops, casting, strings, arrays. Let's think about stack or the heap. Good luck. I mean, you got all these things to implement first. This, I'm not sure how many parts this will be if I do ever finish this, because I never actually finished the LLVM. LLVM's complicated. It's complicated to convert to. It will probably be at least 50 parts, depending on how far we get. Anyway, so where the hell am I? So yeah, we append this. So basically just like the type and then the name. Ironically, I don't know why. So LLVM uses the C++ syntax of type name equals value. In some situations it doesn't. Don't know why. It's kind of weird. So here it just says name equals. It's like Python, but then we have to specify the type. We specify the type on the right. It's kind of weird. That here it's like C, C++, C sharp. You have type name. You have type function, type name. Weird. Here you have name equals value type add. It's kind of weird. The syntax is kind of weird. Anyway, so LLVM kind of uses that kind of syntax. So it's like type first, which I always preferred. I don't know why everyone flips to the opposite, because everyone, even Zig does, the const. They would say value colon i32 equals or whatever, and then kind of prefer inferred types, because I don't like. Anyway, I'm kind of going off on a tangent. What else did we do? I don't remember, because it's been so long. Yeah, I have process return, so we have to kind of, yeah, this is one you need to know. The process return, before it was very simple. Now it's a bit more complicated. We have the statements, which is an array list. We're just putting it, this is just literally just creating the array list, putting it on the heap, just because I don't want to deal with that, and it will get cleared anyway because we're using an arena allocator. Maybe you can put it on the stack. I don't really care. I can't be bothered to really think about it. And then we just set it to init capacity. Yeah, so just creating an array list. And then we flatten the expression. So we get basically we'll get an array list of strings, and then we have to basically put those in order. Because basically what it could be, I say the word basically a lot. So it could be, say for example, we have, I don't know, return a plus b. What we need to do for that is we need to create a variable called, I don't know, say return value. Say return value i32 equals add i32 a and b. That's the LLVM way to write it. And then we just return the value. You cannot return add i32. Doesn't work. It's got to be one instruction per line. So it's like we add and then we return. You can't add and return at the same. No, you can't do it. So what we're basically doing is, if it will separate this into a line and then this into a line. That's what it will do. So we're basically, if it's multiple, it could be multiple. It could be multiple. If you say, for example, you want to do add this plus this plus this plus function call, you have to separate those into 3 different lines entirely, and then you print out all of these lines like this. You print out all the lines, and then you just print out the return, again presuming it's an i32. I'll do it later. So we're presuming everything's an i32, and we still haven't even done yet. Anyway, so I don't know if I'll try to go through the code at the end, so you can copy it if you want. I'm probably going to forget loads of stuff. I did also add LLVM utils. I added this thing, convert to LLVM operator, and we again presume it's an i32, so we don't go insane, because that's going to be later. Because later we're going to have to track the types of everything. Also, just to be really annoying, we have different types of divide depending on if it's signed or unsigned. So we have to track if it's signed or unsigned. We have to track the type if it's signed or unsigned, and then we have to return and put this here depending on what the type is. And then we do that either before or after we go insane, but I'm not sure which order you go insane first. But yeah, anyway, LLVM is hard. I might, for my own sanity, switch to converting. If you convert to Go, it's very simple, because there's no garbage. There's this garbage collection. You don't really need to think about it. It would actually be very easy to convert this. I could probably finish this in a month if I convert to Go. But we'll see. I mean, maybe you can make it an option. You can make an option to convert to Go, C++, or LLVM. I don't know. We'll get there when we get there. Anyway, probably this is just even more scatterbrain than usual, because I thought, okay, I'll just do this. I'll just implement this, and it took me a day and a half, and I was just writing a load of stuff. So what I wrote this time was expressions. I have fill parameters, and we have all this, and we have all of this, all of this, all of this, all of this, and we have all of this. And then I think I have also, I forgot about this. This is just endless cycles. Endless cycles. In parse binary expression any, I had to have enter a value and identifier, and I have to pass the process identifier, which I don't remember what it does at all. Yeah, we have process function, because it could be a function call. Because, say for example, you do this. You go, can't even think what I'm doing. Let's say, in number equals thing. What's thing? Is it a function call? Is it this? Is it that? Is that? So we look, is it a left parentheses? If it's left parentheses, it's a function call. Okay, we got a process function call. Or it could be equals thing. Is it? Oh, it's a semicolon or a full stop or something else. I don't know. Or we presume it's an identifier, if anything else. But if it's a dot, then it could be a struct, or it could be another file from another thing, or it could be a bracket, which means it's an array access. Sorry, it could be an array access. So we've got to basically do this, and the function call is a load of fun. There's so much code. Literally, all I'm doing right now is just printing a return. There's so much code just to do that. Now, array access. Again, I don't remember how array access works. I guess we pass binary expression. I don't know. And then we don't even need to care about this right now. We just really just care about this part. We just want an identifier. Because we're not using function calls yet. We're not doing array access. We're keeping our sanity for now. But that's all. That's what I did. Yeah. So that was this scatterbrain of an episode. Let me know if you have any questions. It's probably all over the place, but I'll see you guys next time.